use the method of joints to analyze a truss. Now we're going to look at the method of sections. This takes advantage of the rule that if the entire truss is in equilibrium, then each section of the truss must be in equilibrium. And if you only need to find the axial force in a couple members, this is going to be a more efficient method. So for example, in this truss, if I just want to find the axial force in HG and HE and DE, then rather than start here and find the axial force using the method of joints all the way to get over to these members, what I can do is cut my truss right here, and then the portion on the left must be in equilibrium and the portion on the right must be in equilibrium. And you can choose either section to analyze. In this example, I'm going to choose this right section to analyze because one is going to be a lot less math because it's a smaller section, fewer forces on it. And also, I don't even need to find the reactions at A and K if I am solving this side of the truss. So I'm going to redraw that part of the truss. And I have joint E, F, and G. I have an applied force of 1,500 pounds at E, an applied force of 1,500 pounds at F. And then where I cut the truss, these now become external forces to this section of the truss. So I will have a force HG, I have a force HE, and I have a force DE. So these three forces are now external to this part of the truss. And now I have three unknowns and I have three equations to use to solve for these three unknowns. I have the sum of the forces in the x direction must be 0, the sum of the forces in the y direction must be 0, and the sum of the moments about some point must be 0. So when you're solving this, you want to pick a point to begin with that's going to make the most sense to make the math the easiest. So I'm going to start by taking the moment about E, because I have two unknowns that go through E, which means that they apply no moment to E. And so my only unknown will be HG, and I can solve for that using one equation. So if I do that, the sum of the moments about E, take this direction, be positive, must be 0. And so I have HG, and this distance is 4 feet, so times 4. This 1,500 pounds also goes through E, so then I have my other 1,500 pounds, and that distance is 3. So when I solve for HG, I will get 1,125 pounds. It is positive, which means I drew it in the correct direction, so it is in tension. Once I know that, I can now solve for HE. I guess I could have done that to begin with the sum of the forces in the y direction. And that must be 0. So I will have HE, and this is a 3, 4, 5 triangle. So this is 3 feet, 4 feet, so 4, 3, 5. So HE 4/5 minus 1,500 minus 1,500. And so HE is 3,750 pounds, and it is pointing up or away from this joint in the direction I drew, so it is in tension. And then finally, I can use the sum of the forces in the x direction to solve for DE. And so I will have HG, which is going to be negative 1,125. I will have minus DE, and I will have minus HE, so 3,750, and that is going to be 3/5. And so DE turns out to be negative 3,375 pounds, So I know that I drew it in the wrong direction. So this is 3,375 pounds, but in compression. So DE, and where's HG? Right there. So these are the axial forces in these three members. So when you're doing the method of sections, you want to cut your truss where there's only three unknowns, because if you have more than three unknowns, you're going to have indeterminate. You won't be able to solve with the three equations. So you want to cut through a section that only has three unknowns. And then again, you can take either the left or the right or the top or the bottom, depending on how you cut it, and use your three equations of equilibrium to solve for the axial forces in those members.